got a lot smaller group than my Go talks on Wednesday, but that's sort of good. It means we'll actually get through all the slides probably. And we can have lots of discussions. If you guys have any questions or comments, commentary, or suggestions, or whatever, we can discuss anything you guys want to. So this is a hardware project I did last year. I was working for, my background is mostly in software, but I was working for a company that made a hardware product, and as I worked longer there, I got more and more interested in hardware. And I decided I wanted a project I could do at home to learn more. So, how many of you guys do hardware stuff? Like, have done any hobby, Arduino? I'm seeing some wavy hands. That's good. I'm probably also a bit like that. So this is kind of just, I'm going to go through my learning experiences and hopefully help foster some ideas and things that you can do. And yeah, go from there. So I have 3 kids, 6, 4, and 1, 7, 4, and 1, and I wanted to. This was before our hardware project started, but I found. You guys ever heard of Ben's Bargains online? It's a bargain website. You go on and it shows you all the deals. I saw this on there one day, and it was like $10 or $15, and it's kind of like this sort of 3-dimensional moon surface, and when you turn it on, it lights up and goes through the lunar phases. So it comes with this remote, and then there's the big button that just kind of cycles through the phases. And when it's really dark in the remote, it's pretty cool. I don't know how dark we want to get in here, but one of these goes off, down one.
Try just hitting off on that little panel.
Off?
Yeah, it'll shut everything off.
Alright. So, anyway, we'll go through the phases. And then there's this other little button down here that starts automatically cycling through. So if you just sit, oh wow, it just cycles through. I thought it was a pretty cool nightlight, and I hung it up in my girls' rooms. They stayed in the same room at the time. Hung it up on the wall, and they really liked it. But I didn't anticipate a problem, which was I'd tuck them into bed, I'd give them this remote, set them down, and then 2 o'clock in the morning, one of them would wake up, and the moon falls asleep after a certain amount of time. And they were obviously not didn't have a presence of mind to find a remote, so they would just yell. So they'd yell, Dad, Mom, the moon's off, and then we'd have to wake up, go down the hall, find the remote, and turn it on. And it got to be kind of a pain. Like 1 or 2 times a night, we'd have to wake up in the middle of the night and go turn the nightlight back on. So that kind of gave me an idea. I had never done anything with, this is an infrared remote, if you can gather, just like a TV remote. I hadn't done anything with infrared before, or Arduino. And it gave me an idea to put some stuff together. I had won an Arduino in an online contest just a few weeks before that, and I thought I could put it to use. So this is the thing that I won. It's the SparkFun Inventors Kit, and it's pretty cool. It's about $100, but it comes with an Arduino, a breadboard, a bunch of LEDs, a bunch of sensors, and it doesn't picture it here, but one of the coolest things it comes with is a little booklet that basically, here it is, that basically has a bunch of different projects you can do. And then you can see, I was trying to use the remote from my laser pointer. You can see, I don't know if it shows it here, but on your breadboard, it comes with, I call them maps, but they're basically overlays that show you where to put in your pieces and wires and run them to the Arduino. It's really, really simple and really fun. So I started tinkering around with basically the sensors that came with that, but I didn't have any infrared sensors and other sensors I need. So what I decided to do for this project was, no, there's a picture of my Arduino and breadboard. Does everyone know how breadboard works? Does anyone not know how breadboard works? Okay, great. So what I decided to do is I would get a microphone sensor and an infrared emitter, and when the girls would wake up in the middle of the night and yell for me, I would sense the sound and just emit the signal to the moon. Problem solved. I'd have to wake up, and they were happy. So that was the plan. So I got Arduino Uno. This is basically the specs on it. If anyone cares, any questions, just blurt them out, please. That's kind of how a breadboard works. You guys said you already knew, so I won't go over it. But so I found this. Well, first I knew somehow, I had never done any of this before, so somehow I knew I would have to figure out what signal was being sent from my remote. So I knew I would need some sort of receiver. So I went online, SparkFun, which if you guys haven't been there before, it's a great place for hobbyist hardware. So this is just a little SparkFun breakout board. It's $10, which I thought was kind of expensive. Most of the infrared stuff is pretty cheap, but I bought it, and so I knew I needed some way to read in the input. So I also bought an infrared LED kit. So infrared just uses it's just another light emitting diode LED. It's just not visible. One kind of cool hack you can do when working with infrared is some cameras will pick up the light so you can test to make sure you're actually sending a signal out. You can take a picture or look at it through your viewfinder of your camera and see the light. And I found a microphone, and this was probably the hardest thing to find, because I kept reading reviews about microphones, and everyone would just complain, like, this doesn't work, or I have to speak really loud, it's not practical. And finally I found a good review on this guy here, but it was part of this Grove sensor ecosystem where you put this little green thing, they call it a shield, that pops on top of an Arduino, and then it's got a bunch of custom Grove headers like here that it's plugging into. So I got it, and I knew that it had pins. I saw from the graphics that it had an input, power, and ground, so I figured there would be some way to tap into it without needing the extra drill thing. So all I bought was this little sensor right here. And then I started putting things together. So this is a picture of this guy here. So that's all put together and nice. And this is how it came in the package. And I had never soldered before at this time, so I was like, oh, well, I guess now it's time to start. So this one here. Next slide, I think, is a picture of my very first attempt at soldering. In retrospect, I probably should have just tried it out on something that I didn't only have one of, and that didn't cost much money. This was only $3, but I ordered it. It took a week to get here. I just started melting things. So this is my first soldering attempt ever. So you can see here, I burnt the PCB. These things were terrible. I should have taken a picture even before I did this, but I took just wire cutters and snipped the tips off of some of these, but they were gigantic. Little mounds, globby things. This one's, I don't even know what happened there. But it worked. I got my multimeter out and put it on all the traces and made sure that I got signal, and it still works. So this was my second attempt with the kit from Radio Shack. So I just went to Radio Shack. They have little electronics kits. after this debacle, I knew if I ever wanted to work on something again, I should get a little practice. So this was the second attempt. I think this isn't I don't have a picture of the other side, but basically it's a little spinning kind of wheel of fortune with LEDs. It takes a 9-volt battery and just plays. So my slides all, by the way, are available on GitHub. So there's some good links in here. My slides are based on, I use the same slide program for my Go talks. So you actually have to have Go to run these, so I apologize. I maybe should have just done these in a regular slide thing, but I was in the group with my other slides. So there's a README on the GitHub on how to actually run these. And it's kind of neat anyway, because these slides, just as an aside, if you have some code you want to demonstrate, it'll actually run and execute code in the slide itself and pop up a little window and show you your code. I don't have any code in this one, but so this is what I ended up doing to the microphone sensor. So instead of using their little proprietary, it's not really proprietary because it's all open hardware, but their special shield and ecosystem for the Grow, I just chopped off the wires that were, if you go back to here, I just chopped off these wires here and soldered on some breakout pins. So ended up like that. And the cool thing about this microphone sensor is it has a potentiometer here built into the circuit, so you can take a little screwdriver and it basically tunes the sensitivity of the microphone. So I didn't have to worry about trying to do anything with that outside of the circuit.
Do you remember how much
this guy?
Yeah.
It was pretty cheap. I know it right now, actually. It's called the Grove Sound Sensor. That's a wiki. Here's one for $5, $6. You know, he has it for $5. It looks like so about
Cool.
$5. Yeah. And it works really well. Kind of. Mine's gotten a little flaky, so hopefully we don't have any technical difficulties. But also, it's been through the war. Kids have used it and stuff. So I don't have anything really bad to say about it.
So curious, I got a question.
Yeah.
If what you're wanting is just to keep the light on, instead of using a microphone, maybe like a light sensor to see if it's dark in the room, turning it on?
Yeah, that's a good point. And it's actually, I have a thing here that says next steps. So the reason I didn't do that is because I wanted to conserve batteries. So this takes four AA batteries, and it burns through them pretty quickly. So I only wanted it on when they cared about it, instead of just staying on the whole night. Another thing I could have possibly done to work around that is maybe done something to plug it into the wall, but yeah. Does that make sense though? Like if it was dark all night, then I didn't want it to. But I think that in combination, because now I have to go turn it off during the day because they're loud during the day, and then it's running and wasting batteries during the day. So I think it's a good idea. I think it would work really well in combination with the sound sensor. So after I got it all those things ordered and put together, this is what I came up with. So this is first prototype. Here's the microphone plugged in, the breakaway pin header pins. There's the receiver. Notice I didn't have it turned on when I took this picture. There's no power or ground because I had already captured the input and didn't need it anymore. So I put the wires over here. And here, it's a cool picture because I think you can kind of see the light emitter. I don't have any wire today. Okay, so step one was to detect sound. So, which time did we have until 11:50?
Yeah.
Okay.
So you got about a half hour.
Okay. So to detect sound, engineering was really simple. And all of this, once I got all of the hardware figured out and put together and soldered, and kind of the general strategy, all the software was pretty easy. I'll get into the little bit of hurdles I had, but at least for the microphone, it was pretty easy. So there's just this reed sound sensor sketch that I adapted from something else, and basically I set this threshold, which it was just, I don't really even know what this threshold actually means. It's just some digital, it's from the analog coming in, just printing out some values. And I just kind of read the values that were coming in and tinkered around to see where I wanted the threshold to come in. So I think this still works. I tested other ones last night, but I forgot about this guy. It should still work though. So let's give it a shot. We'll time like the present. And then send it over. And then look at our serial number. So here it's kind of just printing the values as it sees them. These are all below. Oh, there was one that popped above the threshold. So if I start talking louder, it should start spitting out that it's singing noise. Did you guys see that?
Mm-hmm.
It's all back. Hello! Yeah! Anyway. So once I got that working, it's super simple. Just check, do an analog read on that pin. And if the sensor value is above the threshold, print noise. And if it's not, just print the sensor value, but it's waiting like 1,000 ticks between each print, so it doesn't completely saturate the screen. So I got that working, and then then I started tackling the infrared part. That was just for the speaker, not a big deal. Infrared, I thought would be really simple, kind of the same way. It turned out to not be so. Infrared is cheap and it's widespread. It's on all your TVs and electronics and receivers and DVD players and all that stuff. There's like kind of some cool things you can do with infrared. But it's almost like there's a protocol for every single device that's out there. It's not really the case, but there are a lot, and some of them make up their own protocols, some of them don't use, a lot of them don't use kind of the main protocols. And then line of sight, obviously, and I couldn't find a lot of software support for infrared stuff. So here are some quotes that I kind of gathered along the way. That Arduino.cc is just the Arduino webpage. So fortunately, there are almost as many infrared protocols as there are devices that use them. And then Wikipedia, the lack of standardization creates many problems for consumers, such as universal remotes that do not adequately control all devices. I have a Westinghouse TV, for example, that I couldn't get any universal remotes to work with at all. For whatever reason, it was just like this remote. And then there was the guy at work. It's like, oh yeah, this would be super easy. You just use the infrared protocol and you won't have any problems. That guy who's wrong. So step 2 in the process was decoding the signal. So like I said, I knew this guy was emitting something, and I needed to be able to capture it and replay it. So decoding the signal, I Googled and Googled and Googled about how to do this, and read a lot about infrared stuff, and eventually found this guy's blog, which people still reference today. It's just a blog post from 2009. I think I have a link to it in my slides, but it's basically this guy's library for infrared controlling for receiving and emitting infrared signals. It's called IR Remote, and it's written in C++, and I just released it in a tarball. I think it eventually made it to GitHub a couple of years ago, but it was just out there on his blog entry, and kind of anything I could find about Arduino infrared eventually ended up at this guy's thing. So there's this infrared record sketch. Now again, this is all out on GitHub. And just basically set up the pins. You start, do some setup here, 9600 baud, and this is using his library to try to decode. And what it tries to do is detect whether it's NEC or Sony, RC5, RC6, some well-known protocols. But if it doesn't know them, it will just receive it on the code, saving as raw. So if I run this, shows serial number. Okay, there we go. So I just took my remote here and I pointed it at the Arduino. I started pushing it, and seeing values come back. It's like, great, that's awesome. I didn't really know what they meant. I still don't know exactly what they mean. So I could get deeper, definitely, into learning more about the actual infrared technology, but it ended up, at least for what to accomplish my goal, not having to wake up in the middle of the night. It wasn't necessary, because the next thing I did was use this guy's, I then wrote my moon control. Well, let me show you this, the library first. Okay, so I'll just look at his public interface here for IR Remote. And you notice he's got several different decode types: Dish, Sharp, Panasonic, NEC, Sony, Mitsubishi, and unknown, which of course was the one that I got. So if you get one of the well-known types, then he just gives you some relatively simple methods, abstractions for decoding those specific kinds and sending them back out. But he also, as I was reading through this, I saw this send raw function. I was like, oh, that sounds like it could be helpful. So basically what I did is I just took these values that were getting printed out here and popped them into an input for that method, and sent it in to this send raw, and there's my signal buffer of those values. So I had the two different buttons. So there's the increment phase mode where you push the button and it cycles through the phases. This guy here. And then there's the other button that does the automatic thing. So those were the values I was getting for both of those. So I just popped them in, and it started working. So I had to figure out the hertz. That was mostly just from reading online, infrared and hertz, googling and figuring that out. Same with the baud rate. Oh, sorry, hertz 38. there's a small range, I think it's like 35 to 40 that's valid for infrared, something like that. I may have taken this remote apart and read the PCB. I know I at least tried to get more information out of it. So, anyway, this it's got it working, and back to the slides. So this was the first deployment in the bedroom before the girls went to sleep. So there's the moon on the wall, and this is how they reacted. It was not quite what I expected. So that obviously wasn't going to work, and that's when I implemented the other button that does the phases, and then when they yell, the way the moon reacts to the phase button is it just keeps it phasing through the phases. So we should be able to recreate that here. So I've got my moon control code, and the increment phase is enabled. Compile that, and send it in, and then we should see something similar here. If I get the infrared pointed in the right direction.
Pretty awesome.
Yeah, so it was fun. It was a fun project. And mission accomplished. There was, if you guys want to see the other mode, but basically it's not as fun because you can't control it. When you make a noise, it just keeps it going through the phase stuff. If it's off, it restarts the phase. So it's not as fun. But it helps me sleep. Let's see. So here's some next steps. Add a light sensor that you brought up. It would be cool so I could leave it on or just leave it plugged in during the day, and then not have to go and plug it in the morning, because then if the light, they can do a test if the light's on, or if the light's on, and don't even just exit, don't even do anything. And then one thing I wanted to do just for my own benefit is put it on a PCB. So actually go through and do the layout of the board, take it from a breadboard Arduino prototype to laying it out on an actual PCB, which is totally doable nowadays because SparkFun, they have all of their libraries are out on in an Eagle format. You guys heard of Eagle? Okay, let me bring up Eagle. Some people haven't, some people haven't. So I'll just so you can at least see it. So this here, it kind of looks like an AutoCAD program. I mean, it's made by a CAD company, I think. Open a board here. I've got some on my desktop. So I just went out to SparkFun last night and downloaded the spec and the board file for the infrared emitter, the infrared LED, and that breakout board. And so it's just right here. And then I went into my libraries when I was configuring this. I won't do it right now, but it was pretty easy. I can't remember exactly what it was. I just Googled for SparkFun, adding SparkFun libraries to Eagle, and I went through and added them in. And now when I go and I look through this, where's the information? Yeah, when I go and look through this board, it says, oh, this is from the SparkFun library. Here's the value. And if I look up this value, on sparkfun.com and just do a search, it's this transistor right here that sits right in the middle of that breakout board. And then you can bring in your own. So down here, I'm going to go to add beach ball. Now it shows me all my SparkFun stuff. And I can just start bringing in 3mm LED. Oh. All right. But anyway, that's the idea. So that's, and then once you've done your Eagle layout, you can show it to someone that knows more than me about layout to make sure that it looks good. And you generate your Gerber files, and then you send Gerber files to one of these board companies that does, it's kind of like group. For hobbyists, they take a big, they basically outsource it to a larger PCB company, and then, but what they send to that larger PCB company is basically a Gerber of everyone, a bunch of different people's projects combined, so that they get the volume discounts. And it costs about, for 3 boards, which is I think the minimum for the ones I saw, at least $5 to $10.
Per board or for the total?
Parts. What's that?
Per board or total?
For 3, yeah, plus your parts. And it takes about two weeks because they have to get them all queued up and enough people to send out an order. And then when you're doing it, remember an Arduino, you've got a USB port, an EEPROM to store things in. So you probably want to do something similar on your own board so that you're able to program it. I haven't done this yet, so I don't know a lot about it, but I've talked to people that at least know a lot about it, and this is kind of the tips I was given. So we've got, any more minutes? We've got 15 minutes.
Yeah.
So, do you guys have any questions about that project or anything like that?
You said you had it on GitHub. What was the URL?
Yeah, it's GitHub/VG Merrell. Here's my presentations, first of all, and some instructions on how to run them. And then it's under Arduino sketches, and there's just files there. Libraries, infrared remote library with the C++ files for doing infrared stuff. Yeah. So I thought we might get through the slides quicker on Saturday with less people. So I also added just some bonus things I've been doing in here. If anyone is interested, there's so this was a cool project I did too. I probably could have done my own presentation with a demo. It was pretty fun. So again, I have kids. My most recent kid loved to swing. That was like the only way he would go to sleep, be happy, anything. So we burned through a swing, and they're, you know, the kind of swings I'm talking about, like the big baby swings that they're stand on the ground, they're like 4 feet tall and swing. Plug into the wall. First of all, we had to find one plugged into the wall because lots of them take batteries, and we didn't want to spend all that money on batteries. So I found one plugged in the wall, and then it burned out. The motor just gave up. And there's like 100, they're kind of expensive, 100, 150 plus, something like that. It's like, I don't want to go buy a new swing. So I found this guy's guide online. Hopefully it works. This is kind of a cool one. Okay. Shouldn't rely on other people's websites apparently for the demos. Anyway, we'll see if that loads. But basically, you've got the top here. So up here, you can kind of take this off, and there's basically just a little tiny motor. It surprised me. It's about yay big, and it's driving this mechanism that just swings the swing back and forth. So, as it turns out, the Glade, what are they called?
Air fresheners?
Yeah, wall air freshener. What is it?
Outlet, right?
Freshmatic, yeah. This guy here. My internet is just slow. Yeah. Oh, this is a kit. But anyway, it turns out that this guy uses the exact same motor. So I went to Walmart and I bought one of these. It was like $8. I had never used it. Just took it out of the box, took it apart. And I'm pretty sure you get them for a pretty good price because they're kind of relying on you buying the new recharges, the new fresh, whatever they're called. So Glade Freshmatic motor. And let's see if I can find. Oh, anyways, this is from that same website, but that's it right there. And then let's see if that's loaded yet. For your air freshener. Okay, now we're getting to it. So basically, you take your swing apart, and your motor sits down in there, and you have to. I'm trying to get to the one thing that you actually have to do other than just pulling out the motor. Oh yeah, it's sitting down in there like this and driving this gear, and that's how it does the thing. And then, yeah, there's the comparison. So okay, so this is what I was looking for. So when you get into your swing, it'll look something like this. It's got a little diode and a
Capacitor.
yeah, the old style that kept, what are they made out of? I don't know, anyway, capacitor. And then you just have to take that off, just pull them off and solder it onto your new one and put it back in the swing, and you're in business. So that one was pretty fun. Saves you a lot of money. You have kids that like to swing. And then another thing I've been working on is, so we moved into a new house a couple of years ago, and the previous owners did the sprinkler system, and they made some poor choices. We've had a couple of floods, so I'm paranoid of water now getting into my house. There's a Spark Fun kit that a breakout board for sensing water and emitting an alarm with a little piezo thing. Except for that wasn't enough for me. What I want to do is I don't want a piezo alarm because I want to know if I'm home or not. If there's water. I thought maybe put it down in like the water heater room and a window well near our sprinkler box, maybe under a sink or something like that. And there's these little. I got too many tabs open now. Sorry. There's these little things called Motinos, and they're based off of Arduinos. They're about yay big, and they have a little wireless radio transceiver built in. They're a little bit pricey still. They're like, I think they're around $25. But my idea is to hook up a water sensor to one of these, and then have a kind of a receiver Motino hooked up to my Mac Mini, and then receiving data from the other ones. And if they sense data, read that into the Mac and then use all the wonderful web APIs to like send me a text message or Twitter or something like that.
What's the range on one of those?
I think, shoot, someone told me once, it's plenty long for what I'm doing. I don't know if it, I don't want to,
Does it go through walls pretty well?
yeah, I think so. Someone at work was doing one. Do you know Chris Nosak? He's at Fusion. He's worked with these, and he was doing some stuff through walls. I don't see it off the top of my head, but yeah, from what I have read and been told. Oh yeah, see, we've got. Not sure which one of these actually comes on the one I want, but yeah, you get pretty good range. So anyway, I think that would be a fun one. That's probably next on the list. And then my daughter had a science fair. My 7-year-old had a science fair recently, and she wanted an idea, and I just gave her that Inventor's Guide booklet. And I said, just go read through these and pick one that you think will be interesting, and we'll do it. And she's in piano lessons, so she picked a music-related one. And basically, I just took the kind of the example code from the booklet, and it gave us kind of the notes and the frequencies to play on that little piezo buzzer. And it was Twinkle Twinkle Little Star originally, and it didn't have, it only had eighth notes and quarter notes, I think. So we added half notes by just increasing the time of waits. So this is basically how many beats each one of these notes should play, and then it iterates through them and plays them. So this will just play a little Old MacDonald song. So Old MacDonald had a farm. Anyway, so and then we found the music online and just plugged in the notes, and you could play anything within a single octave. And you could probably get more advanced and add octaves and things like that. So, anyway,
Did she get a good grade?
what? I don't know. I don't know if they were even graded, but it was fun. So, this is kind of just an aside. The two talks that I gave on Wednesday, the kind of work I'm doing now is around the Go programming language. However, there is some overlap with hardware and electronics. There's two projects, GoBot.io, which is the shirt I'm wearing now to do Go-powered robots, and Embed, which is a new kid on the block that does kind of an embedded library for, it's a library to run code on Raspberry Pis and Beagle Bones. GoBot is kind of a layer of abstraction. I think it's probably quite a bit more mature and full-featured. It's a layer of abstraction on top of Arduinos, Raspberry Pis, Beagle boards, or Beagle Bones, those quadcopter thing drones that have APIs. You can write to those. At the conference where I got this shirt, they demoed a quadcopter with a camera on it that did facial recognition, written in Go, with a Go library to do facial recognition. So the drone would come up and hover in the air and find a face and fly toward it. So it was kind of cool. So that's these guys. They have their own little product called the Sphero. It's a little ball that lights up in different colors that you can program to do interesting things, roll around and fight with other Spheros. Just lots of cool things going on. And then we have just again, this isn't really related to the hardware stuff. We may do hardware stuff here at some point. This is the Utah Go users group. You guys are interested in learning more about Go. So, that's it.